Refrigeration is a process of moving heat from one location to another in controlled conditions. Refrigeration has many applications, including, but not limited to, household refrigerators, industrial freezers, cryogenics, and air conditioning. Heat pumps may use the heat output of the refrigeration process, and also may be designed to be reversible, but are otherwise similar to refrigeration units. Refrigeration has had a large impact on industry, lifestyle, agriculture and settlement patterns. The idea of preserving food dates back to the ancient Roman and Chinese empires. However, refrigeration technology has rapidly evolved in the last century, from ice harvesting to temperature-controlled rail cars. The introduction of refrigerated rail cars contributed to the westward expansion of the United States, allowing settlement in areas that were not on main transport channels such as rivers, harbors, or valley trails. Settlements were also developing in infertile parts of the country, filled with new natural resources. These new settlement patterns sparked the building of large cities which are able to thrive in areas that were otherwise thought to be inhospitable, such as Houston, Texas and Las Vegas, Nevada. In most developed countries, cities are heavily dependent upon refrigeration in supermarkets, in order to obtain their food for daily consumption. The increase in food sources has led to a larger concentration of agricultural sales coming from a smaller percentage of existing farms. Farms today have a much larger output per person in comparison to the late 1800s. This has resulted in new food sources available to entire populations, which has had a large impact on the nutrition of society. History. Earliest forms of cooling. The seasonal harvesting of snow and ice is an ancient practice estimated to have begun earlier than 1000 BC. A Chinese collection of lyrics from this time period, known as the Shiqing, describes religious ceremonies for filling and emptying ice cellars. However, little is known about the construction of these ice cellars or what the ice was used for. The next ancient society to harvest ice may have been the Jews, according to the Book of Proverbs, which reads, "As the cold of snow in the time of harvest, so is a faithful messenger to them who sent him." Historians have interpreted this to mean that the Jews used ice to cool beverages rather than to preserve food. Other ancient cultures such as the Greeks and the Romans dug large snow pits insulated with grass, chaff, or branches of trees as cold storage. Like the Jews, the Greeks and Romans did not use ice and snow to preserve food, but primarily as a means to cool beverages. The Egyptians also developed methods to cool beverages, but in lieu of using ice to cool water, the Egyptians cooled water by putting boiling water in shallow earthen jars and placing them on the roofs of their houses at night. Slaves would moisten the outside of the jars and the resulting evaporation would cool the water. The ancient people of India used this same concept to produce ice. The Persians stored ice in a pit called a yakshal and may have been the first group of people to use cold storage to preserve food. In the Australian outback, before a reliable electricity supply was available where the weather could be hot and dry, many farmers used a coolgardie safe. This consisted of a room with hessian curtains hanging from the ceiling soaked in water. The water would evaporate and thereby cool the hessian curtains and thereby the air circulating in the room. This would allow many perishables such as fruit, butter and cured meats to be kept that would normally spoil in the heat. Ice harvesting. Before 1830, few Americans used ice to refrigerate foods due to a lack of ice storehouses and ice boxes. As these two things became more widely available, individuals used axes and saws to harvest ice for their storehouses. This method proved to be difficult, dangerous, and certainly did not resemble anything that could be duplicated on a commercial scale. Despite the difficulties of harvesting ice, Frederick Tudor thought that he could capitalize on this new commodity by harvesting ice in New England and shipping it to the Caribbean islands as well as the southern states. In the beginning, Tudor lost thousands of dollars, but eventually turned a profit as he constructed ice houses in Charleston, Virginia and in the Cuban port town of Havana. These ice houses, as well as better insulated ships, helped reduce ice wastage from 66% to 8%. This efficiency gain influenced Tudor to expand his ice market to other towns with ice houses, such as New Orleans and Savannah. This ice market further expanded as harvesting ice became faster and cheaper after one of Tudor's suppliers, Nathaniel Wyeth, invented a horse-drawn ice cutter in 1825. This invention, as well as Tudor's success, inspired others to get involved in the ice trade, and the ice industry grew. Ice became a mass-market commodity by the early 1830s, with the price of ice dropping from 6 cents per pound to 1/2 cent per pound. In New York City, ice consumption increased from 12,000 tons in 1843 to 100,000 tons in 1856. Boston's consumption leapt from 6,000 tons to 85,000 tons during that same period. Ice harvesting created a cooling culture, as majority of people used ice and ice boxes to store their dairy products, fish, meat, and even fruits and vegetables. These early cold storage practices paved the way for many Americans to accept the refrigeration technology that would soon take over the country. Refrigeration research. The history of artificial refrigeration began when Scottish professor William Cullen designed a small refrigerating machine in 1755. Cullen used a pump to create a partial vacuum over a container of diethyl ether, which then boiled, absorbing heat from the surrounding air. The experiment even created a small amount of ice, but had no practical application at that time. In 1758, Benjamin Franklin and John Hadley, professor of chemistry, collaborated on a project investigating the principle of evaporation as a means to rapidly cool an object at Cambridge University, England. They confirmed that the evaporation of highly volatile liquids, such as alcohol and ether, could be used to drive down the temperature of an object past the freezing point of water. They conducted their experiment with the bulb of a mercury thermometer as their object and with a bellows used to quicken the evaporation. They lowered the temperature of the thermometer bulb down to 7 degrees Fahrenheit. While the ambient temperature was 65 degrees Fahrenheit. They noted that soon after they passed the freezing point of water, a thin film of ice formed on the surface of the thermometer's bulb, and that the ice mass was about a quarter-inch thick when they were stopped. The experiment upon reaching 7 degrees Fahrenheit. Franklin wrote, "From this experiment, one may see the possibility of freezing a man to death on a warm summer's day." In 1805, American inventor Oliver Evans described a closed vapor compression refrigeration cycle for the production of ice by ether under vacuum. In 1820, the English scientist Michael Faraday liquefied ammonia and other gases by using high pressures and low temperatures, and in 1834, an American expatriate to Great Britain, Jacob Perkins, built the first working vapor compression refrigeration system in the world. It was a closed cycle that could operate continuously, as he described in his patent. "I am unable to use volatile fluids for the purpose of producing the cooling or freezing of fluids, and yet at the same time constantly condensing such volatile fluids, and bringing them again into operation without waste." His prototype system worked, although it did not succeed commercially. In 1842, a similar attempt was made by American physician John Gorrie, who built a working prototype, but it was a commercial failure. Like many of the medical experts during this time, Gorrie thought too much exposure to tropical heat led to mental and physical degeneration, as well as the spread of diseases such as malaria. He conceived the idea of using his refrigeration system to cool the air for comfort in homes and hospitals to prevent disease. American engineer Alexander Twining took out a British patent in 1850 for a vapor compression system that used ether. The first practical vapor compression refrigeration system was built by James Harrison, a British journalist who had emigrated to Australia. His 1856 patent was for a vapor compression system using ether, alcohol or ammonia. He built a mechanical ice-making machine in 1851 on the banks of the Barwon River at Rocky Point in Geelong, Victoria, and his first commercial ice-making machine followed in 1854. Harrison also introduced commercial vapor compression refrigeration to breweries and meat packing houses, and by 1861, a dozen of his systems were in operation. He later entered the debate of how to compete against the American advantage of unrefrigerated beef sales to the United Kingdom. In 1873 he prepared the sailing ship Norfolk for an experimental beef shipment to the United Kingdom, which used a cold room system instead of a refrigeration system. The venture was a failure as the ice was consumed faster than expected. The first gas absorption refrigeration system using gaseous ammonia dissolved in water was developed by Ferdinand Carré of France in 1859 and patented in 1860. Carl von Linde, an engineer specializing in steam locomotives and professor of engineering at the Technological University of Munich in Germany, began researching refrigeration in the 1860s and 1870s in response to demand from brewers for a technology that would allow year-round, large-scale production of lager. He patented an improved method of liquefying gases in 1876. His new process made possible using gases such as ammonia, sulfur dioxide and methyl chloride as refrigerants, and they were widely used for that purpose until the late 1920s. Thaddeus Lowe, an American balloonist, held several patents on ice-making machines. His compression ice machine would revolutionize the cold storage industry. In 1869, other investors and he purchased an old steamship onto which they loaded one of Lowe's refrigeration units and began shipping fresh fruit from New York to the Gulf Coast area, and fresh meat from Galveston, Texas back to New York, but because of Lowe's lack of knowledge about shipping, the business was a costly failure. Commercial use. In 1842, John Gorrie created a system capable of refrigerating water to produce ice. Although it was a commercial failure, it inspired scientists and inventors around the world. France's Ferdinand Carré was one of the inspired, and he created an ice-producing system that was simpler and smaller than that of Gorrie. During the Civil War, cities such as New Orleans could no longer get ice from New England via the coastal ice trade. Carr's refrigeration system became the solution to New Orleans' ice problems, and by 1865 the city had 3 of Carr's machines. In 1867, in San Antonio, Texas, a French immigrant named Andrew Moule built an ice-making machine to help service the expanding beef industry before moving it to Waco in 1871. In 1873, the patent for this machine was contracted by the Columbus Iron Works, a company acquired by the W.C. Bradley Co., which went on to produce the first commercial ice makers in the U.S. By the 1870s, breweries had become the largest users of harvested ice. Though the ice harvesting industry had grown immensely by the turn of the 20th century, pollution and sewage had begun to creep into natural ice, making it a problem in the metropolitan suburbs. Eventually, breweries began to complain of tainted ice. Public concern for the purity of water, from which ice was formed, began to increase in the early 1900s with the rise of germ theory. Numerous media outlets published articles connecting diseases such as typhoid fever with natural ice consumption. This caused ice harvesting to become illegal in certain areas of the country. All of these scenarios increased the demands for modern refrigeration and manufactured ice. Ice-producing machines like that of Carr's and Moule's were looked to as means of producing ice to meet the needs of grocers, farmers, and food shippers. Refrigerated railroad cars were introduced in the U.S. in the 1840s for short-run transport of dairy products, but these used harvested ice to maintain a cool temperature. The new refrigerating technology first met with widespread industrial use as a means to freeze meat supplies for transport by sea from the British Dominions and other countries to the British Isles. The first to achieve this breakthrough was an entrepreneur who had emigrated to New Zealand. William Salter Davidson thought that Britain's rising population and meat demand could mitigate the slump in world wool markets that was heavily affecting New Zealand. After extensive research, he commissioned the Dunedin to be refitted with a compression refrigeration unit for meat shipment in 1881. On February 15, 1882, the Dunedin sailed for London with what was to be the first commercially successful refrigerated shipping voyage, and the foundation of the refrigerated meat industry. The Times commented, "Today we have to record such a triumph over physical difficulties, as would have been incredible, even unimaginable, if very few days ago." The Marlborough, sister ship to the Dunedin, was immediately converted and joined the trade the following year, along with the rival New Zealand shipping company vessel Mataura, while the German steamer Marsala began carrying frozen New Zealand lamb in December 1882. Within 5 years, 172 shipments of frozen meat were sent from New Zealand to the United Kingdom, of which only 9 had significant amounts of meat condemned. Refrigerated shipping also led to a broader meat and dairy boom in Australasia and South America. J&E Hall of Dartford, England outfitted the SS Alembria with a vapor compression system to bring 30,000 carcasses of mutton from the Falkland Islands in 1886. In the years ahead, the industry rapidly expanded to Australia, Argentina and the United States. By the 1890s, refrigeration played a vital role in the distribution of food. The meat packing industry relied heavily on natural ice in the 1880s and continued to rely on manufactured ice as those technologies became available. By 1900, the meat packing houses of Chicago had adopted ammonia cycle commercial refrigeration. By 1914, almost every location used artificial refrigeration. The big meat packers, Armour, Swift, and Wilson, had purchased the most expensive units which they installed on train cars and in branch houses and storage facilities in the more remote distribution areas. By the middle of the 20th century, refrigeration units were designed for installation on trucks or lorries. Refrigerated vehicles are used to transport perishable goods, such as frozen foods, fruit and vegetables, and temperature-sensitive chemicals. Most modern refrigerators keep the temperature between -40 and -20 degrees Celsius, and have a maximum payload of around 24,000 kilograms gross weight. Although commercial refrigeration quickly progressed, it had limitations that prevented it from moving into the household. First, most refrigerators were far too large. Some of the commercial units being used in 1910 weighed between 5 and 200 tons. Second, commercial refrigerators were expensive to produce, purchase, and maintain. Lastly, these refrigerators were unsafe. It was not uncommon for commercial refrigerators to catch fire, explode, or leak toxic gases. Refrigeration did not become a household technology until these 3 challenges were overcome. Home and consumer use. During the early 1800s, consumers preserved their food by storing food on ice purchased from ice harvesters in ice boxes. In 1803, Thomas More patented a metal-lined butter storage tub which became the prototype for most ice boxes. These ice boxes were used until nearly 1910 and the technology did not progress. In fact, consumers that used the icebox in 1910 faced the same challenge of a moldy and stinky icebox that consumers had in the early 1800s. General Electric was one of the first companies to overcome these challenges. In 1911, GE released a household refrigeration unit that was powered by gas. The use of gas eliminated the need for motor and decreased the size of the refrigerator. However, electric companies that were customers of GE did not benefit from a gas-powered unit. Thus, GE invested in developing an electric model. In 1927, GE released the Monitor Top, the first refrigerator to run off electricity. In 1930, Frigidaire, one of GE's main competitors, synthesized Freon. With the invention of synthetic refrigerants based mostly on a chlorofluorocarbon chemical, safer refrigerators were possible for home and consumer use. Freon led to the development of smaller, lighter, and cheaper refrigerators. The average price of a refrigerator dropped from $275 to $154 with the synthesis of Freon. This lower price allowed ownership of refrigerators in American households to exceed 50%. Freon is a trademark of the DuPont Corporation and refers to these CFCs, and later hydrochlorofluorocarbon and hydrofluorocarbon, refrigerants developed in the late 1920s. These refrigerants were considered at the time to be less harmful than the commonly used refrigerants of the time, including methyl formate, ammonia, methyl chloride, and sulfur dioxide. The intent was to provide refrigeration equipment for home use without danger. These CFC refrigerants answered that need. In the 1970s, though, the compounds were found to be reacting with atmospheric ozone, an important protection against solar ultraviolet radiation, and their use as a refrigerant worldwide was curtailed in the Montreal Protocol of 1987.